Let's do a real-world application of linear programming. You are screen printing T-shirts and sweatshirts to sell at a blues festival and are working with the following constraints. You have at most 20 hours to make the shirts. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. Each T-shirt takes 10 minutes to make, costs $4 to make, and has a profit margin of $6. Each sweatshirt takes 30 minutes to make, costs $20 to make, and has a profit margin of $20. How many T-shirts and sweatshirts should you make to maximize your profit? How much is the maximum profit? Well, first we have to figure out what our inequality constraints are. Now, one of them has to do with time, because the T-shirts take 10 minutes, the sweatshirts take 30 minutes, and I don't want to do this for more than 20 hours. First of all, I'm not in the same units. It probably helps if I change everything to be in terms of minutes. Let's call X the number of T-shirts, and let's call Y the number of sweatshirts, so we have variables to work with. So 10X plus 30Y, I have at most 20 hours to make shirts. Well, 20 hours in minutes, 20 times 60 is 1,200. Another constraint I have is that I want to spend no more than $600 on supplies. So my cost is, it costs $4 for the T-shirt, it costs $20 for the sweatshirt, and I don't want to spend more than $600. The other constraint has to do with how many items I want to sell. I want to sell at least 50 items. That means that the number of T-shirts plus the number of sweatshirts has to be at least 50. There are two other inequalities that I'm going to mention, but we don't need them as long as you remember that you can't make a negative T-shirt or a negative sweatshirt. The other two constraints are X is greater than or equal to 0 and Y are greater than or equal to 0. Remember that those restrict you to quadrant 1. But we should already know we're in quadrant 1 because we can't have negative shirts. Now, there is another equation that we have to write, and the last equation we have to write is our profit equation. The profit equation has to do with how much money we're going to make. Well, the profit is going to equal, well, we make a profit of $6 on T-shirts, and we make a profit of $20 on sweatshirts. That is our objective function. That's the function we're going to use after I find the graph, I find the vertices of the feasible region, and then I'll plug them into this equation. So how do you best go about graphing this? Well, it gets really hard to graph these real-world problems, so I would probably graph them using intercepts. So the first inequality, the X, and let me see, I want to do this in different colors. So maybe I'll make the first graph blue. The x-intercept, if you ignore y, is going to be 120, because 1,200 divided by 10 is 120. The y-intercept, ignore x, is going to be 440. I had to think about that for a second. Let me double check that. Let's see. 30 divided by, all right, yeah. Now the second inequality I'll graph in red. The x-intercept, that's if I ignore the y, I'm going to find out is 150. The y-intercept, if I ignore x, is 30. And the last one here I'll graph in green. The x-intercept is 50. And the y-intercept is 50. This is the best way to graph real-world problems. Now, the reason I wanted to find the x and y-intercepts is because I got to think about how I'm going to scale my graph. The book scales at every 15, I think. I don't know if that's the best way to scale the graph or not. I usually like to work in 10s or 50s or 100s. So now I'm going to find a graph. So I usually use this blank grid graph, and then I call the bottom of the grid graph the x-axis, and I call the left-hand side of the grid graph the y-axis. Now, because of the way I set this graph up, since I need to be able to get to 150 on the x-axis, I probably can just call each tick mark 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, that would be 100. 110, 20, 30, 40, and I could probably make one more here and call that 150 because that's as far as I need to go. So now I'm going to go back up here for a minute and start with the blue graph. The x-intercept is 120, the y-intercept is 40. So here's my y-intercept of 40, 50, 40, 30, 20. Here's my x-intercept of 120, and here's my line. Now, if I were doing this on a sheet of paper, I'd be using the side of my ID as a straight edge because this is very important that we use a straight edge for these particular problems. The next graph had an x-intercept of 150 and a y-intercept of 30. So my x-intercept of 150, my y-intercept of 30, and there's its line. Let's try that again. Not a very good line. That's better. Now again, both of these have inequality symbols of less than or equal to, and y is not negative, so both of these graphs are getting shaded below their lines. All right, now I'm going to go to the green graph. The x-intercept is 50, the y-intercept is also 50, so 10, 20, 30, 40, 50, 50, 10, 20, 30, 40, 50. And now I'm going to connect those two lines. The feasible region, since so the first two graphs are being shaded below. The third graph is being shaded above. That means my feasible region is going to be in this quadrilateral. Now the hard part is finding the points of intersection. So I'm going to start with the easiest of the vertices. This vertex here is 50, 0. And this one here is 120, 0. Those are the easy ones. The other two are not so easy. This vertex here is the intersection of the red and green graphs. Well, if I come back up to the top here, the red and the green graphs were these two. We just learned how to use something called a matrix to find the solution to a system. The matrix can show me what the point of intersection of those two lines are. Remember, in order to do a matrix, the equations need to be in standard form. And I know they're inequalities, you can ignore that. We put them in this weird little boxes here where we just use the coefficients, not any of the variables. We have to know how many rows and how many columns are in the matrix. And then I'm going to plug this into my calculator real fast. I'm not going to give the instructions again here on how to use the matrix to find the solution. We'll do it again in class, or I'll do another video. My calculator told me that it intersected at 25, 25. So that's another one of my vertices. And then this vertex here is the corner of the red and blue graph. So I need to find where those two intersect. Here's my red and blue graph. So I need to do 10, 30, 1200, 420, 600, and I'm going to go do a matrix now to find where the point of intersection is. My calculator's telling me that it's at 75, 15. So those are my four vertices. Now I'm going to go back and I'm going to plug them into my profit function, which I said was 6x plus 20y. So if I plug in 50, 0, 6 times 50 plus 20 times 0 is going to give me 300. So my profit will be 300. If I use 120, 0, 6 times 120 plus 20 times 0 is 720. If I use 75, 15, 6 times 75 plus 20 times 15 is going to give me 750. And then if I use 25, 25, 6 times 25 plus 20 times 25 is equal to 650. Well, it turns out that this is the maximum amount of money I can make. So the maximum profit I can make is $750 if I make 75 t-shirts and I make 15 sweatshirts. And that is what we are doing in part 2 of linear programming. We're taking constraints and writing our own inequalities. We're graphing them and finding the feasible region. Notice that I went and used this new method of finding points of intersection to help me find the two constraints on the graph that I couldn't really tell what they were by looking at the graph. And then I used those ordered pairs to plug into the profit function to find out which one would give me the maximum profit and what would be my best scenario for making the most amount of money.